Hello everyone, today we will be continuing our discussion of traveling salesman problems with another method for solving them, and that is the nearest neighbor algorithm. Now the nearest neighbor algorithm is what we refer to as an approximate algorithm. Unlike the brute force algorithm that we talked about in the last video, this is not necessarily going to give you a perfectly optimal solution every time. However, it is much faster and more efficient than using the brute force algorithm because we don't have to try every single possible way of traveling between all of the different vertices in a graph. So the way that we do the nearest neighbor algorithm is basically we are going to have our starting vertex that we pick. So let's say that we are trying to start and end at vertex A for this graph. And the idea is that we are going to pick the edge with the lowest weight that's connected to A. So basically we're going to whichever vertex next that is the nearest neighbor of A. And then we're going to do the same thing from every point after that until eventually we get back to A. So let's start at vertex A. So if we look at this graph, the cheapest edge that is connected to A is this one right here going to D at 8. So we're going to go to D first. And then from D, the next cheapest one is going from D to E, also with a weight of 8. So we go to E next. Now from E, the cheapest one is going to be going to B because the weight of this is only 7. So we're going to go to B next. And then from B, our next cheapest one that we have from B is actually this one going to A, but we don't want to do that because we don't want to prematurely go back to A when we haven't visited C yet. So we're actually going to pick our only remaining option to not visit a vertex 3 times, basically, or not visit a vertex multiple times, and that's going to be to go to C. And then from C, we have to go back to A, because at this point we've already visited all of our vertices that we need to. So now we're just going to add up the weights of all these different edges. So we went from A to D to E to B to C and then back to A. So what this is going to give us is a total weight of 8 plus 8 plus 7 plus 12 plus 9. So if we add all of these up, we get a total weight of 44. All right, so this would be our solution using the nearest neighbor algorithm. So you can see we only had to find one path and one circuit rather. We didn't have to try a million different things like we would have for the brute force method. So this is much faster, as you can see. Now, related to the nearest neighbor algorithm is what we call the repetitive nearest neighbor algorithm. And basically this is just where we run the nearest neighbor algorithm starting at every one of the vertices and see which one has the lowest cost, and then we just rewrite that one so that it starts and ends at A. So if we do that for this graph, the next one that we're going to do is starting and ending at B. So if we start at B, our nearest neighbor is going to be E because it's only 7. That's the lowest that we have connected to B. So we're going to go from B to E. And then we are going to go from E, next our cheapest one is to D. From D, the cheapest one is going to be to go to A. And then from A, our only option at this point is to go to C and then D. So you can see in this case, we've actually ended up with a circuit that looks the same as what we had before. This can happen sometimes with the repetitive nearest neighbor algorithm. So we went from B to E, D, A, C, B. So our total weights are going to be 7 plus 8 plus 8 again, plus 9 plus 12. And this is going to give us 44, as you might imagine, since we used all the same edges that we did when we started and ended at A. Next, we're going to do the same thing with C. So from C, our cheapest edge is going to A. And then from A, D is our cheapest. From D, E to B, and then C. So we've used the same thing again. So C is also going to be 44. So this would be C, A, D, E, B, C, with a total weight of 44. Next, we do this with D. So our cheapest edge from D is actually a tie between going to A and going to E. So let's try going to E. And then from E, next cheapest is going to be to B. From B, our next cheapest one is to go to A. And then from A, our only remaining option is to go to C and then D. So you can see this time we actually ended up with a different circuit than what we got for the first three. So D, we went D, E, B, A, C, D. And our total weight for this is going to be 8 plus 7 plus 10 plus 9 plus 11. So this is going to give us a total of 45. So as it turns out, this is actually slightly worse than the ones that we got for A through C. And then the last one that we have left to try is E. So from E, our cheapest edge is to B. From B, our cheapest edge is going to be to A. And then from A, cheapest is to D. And then from D, our cheapest is going to be going to, well, at this point we only can go to C and then back to E. So we went E, B, A, D, C, E. So our weights are going to be 7 plus 10 plus 8 plus 10 plus 11. And this is going to give us a total weight of 46. So even worse, actually. So in this case, it turns out the first one we tried, starting and ending in A, is actually our best option. Note that that won't necessarily always be the case, but in this case, in this instance, that's just sort of how it worked out. Thank you for watching, and as always, I'm happy to help with questions.